Okay, so let us begin with the next topic. This is very important topic. It will come again and again, right? That is, we are going to talk about the derivatives and integrals. Okay, so the total thing is called as calculus. All right. So now, what is a derivative? Let's try to understand the derivative. So suppose you have this curve. Okay, you have this curve. Then now you take any 2 points on the curve. Okay, you take any 2 points. Suppose I take, I take these 2 points, right? You can call them P and Q, anything you want. So suppose the point P, okay, this curve is y versus x, right? The quantity that we are plotting on the vertical axis is y, and suppose the quantity that we are plotting on the horizontal axis is x. Okay, right? So then the relation between y coordinate and x coordinate is y is equal to f of x. This can be anything, like y is equal to x square can be a possible relation. Okay, so that is known as a function. So yesterday we had discussed when it is known as a function. When is it known as a function? For every value of x you have one and only one value of y, then it's a function, right? So now you plot a curve of y equals to f of x. F of x can be anything. It can be x square, it will be 2x, it can be sin x, something. Okay, so we have these 2 points. This is suppose P, this is Q. So at point P, the x coordinate is suppose x only. Okay, at point Q, let's call them P and Q. So at point P, the x coordinate is x. At point Q, the x coordinate is x plus delta x. That means this much is the difference. So we know that this is called as the run. Okay, we are running along the x axis. So what's change on the y axis? What is the change on the y axis? So this is delta x. Delta x is the run, the change along the x axis. Change on the y axis is suppose delta y. So the coordinate of point P is suppose y, and coordinate of point Q, y coordinate, it is y plus delta y. Okay, so now if we find the rise or run, that means delta y divided by delta x. So what is that? We had discussed that yesterday. What is that thing? Anybody?
Slope.
Yeah, it's the slope. But slope of which thing? It's slope of a line, right? It is slope of a line. Now there is no line here. This is a curve. Okay, so if you plot a line passing through x and y, right? If you plot a line passing through these 2 points x and y, then delta y divided by delta x is slope of that line. Okay, so this is the line. Can you see that? Or let's use different color. This is the line, right? Can you distinguish between the two colors? Okay, this is the line. Now you can see there is a difference between the line and the curve. Okay, it is slope of this line. It is slope of this line. Now when we take this delta x smaller and smaller, what will happen is that this line will approach closer and closer to the curve. Okay, so I'm showing it here. For an example, suppose you take this is the curve, okay, and you take delta x equal to this much. Okay, delta x equal to this much, right? So these are the 2 points. First you take this point and this point. So delta x would be this much. What is change in y? Change in y is this much, right? Then you decrease delta x. So delta x is this much. That means you take this point, suppose. So initially you can see that when delta x is this much, Okay, so this is your first point, this is second point on the curve. Then the delta y by delta x represents slope of this line. Okay, so the line which intersects the slope at two different points, it is known as a secant line. Okay, then if you take smaller delta x, this much, let's say, then that means you are taking this point and this point, you are going from this point to this point, right? Then the slope, then delta x would be this much. So this is your second point, suppose. Then what happens? See, delta y also decreases. Oh, this is the curve, no? Sorry. So you are taking this point and this point. Okay, you have changed the position of q. So this point and this point. So what happens? This is delta x, delta y also changes, right? But what happens to this secant line whose slope is given by delta y by delta x? It comes closer to the curve. Okay, if you take even smaller delta x, that means you are choosing this point and this point. Okay, this point and this point, right? This one and this one. Then what happens? So you will get slope of this line when you find delta y by delta x. So if you take smaller and smaller delta x, that secant line will approach closer and closer and closer to the curve. So one stage will come when the secant line just touches the curve. Okay, the 2 points will be 2 points on the curve. Where it intersects, they will be very close to each other. And even further stage will come where the secant line becomes a tangent. It is no longer a secant line, it's a tangent line, right? So slope of that line is known as a derivative. This is geometrical meaning of derivative. Geometric meaning of derivative. Is this thing clear? Yes, no? Everyone? Okay, good. So now, how do we represent it mathematically? Okay, it is slope of a tangent line to a curve. What is derivative? Geometrically, it is slope of a tangent line to a curve. How do we represent it mathematically? So what we are doing, what's the procedure? We are taking smaller and smaller and smaller delta x. Okay, we are taking smaller and smaller value of change on the horizontal axis, right? So it is represented, so derivative is written like this, dy by dx. It is derivative of the quantity on vertical axis. Here we are taking it as y with respect to the quantity on horizontal axis. Okay, or you can say not quantity, I am talking in terms of physics. Mathematically you can say this is variable, one variable, this is another variable. So variable on vertical axis, variable on horizontal axis. So you are taking derivative of y, this is y with respect to x, it's written as dy by dx. Okay, so what's that? You write delta x is very, very small. How small? It's almost equal to 0. It is approaching to 0. So it's written like this, limit delta x tends to 0. Okay, it means that delta x is delta x is so small that it's almost 0. Okay, then you find change in y. So how are you writing y? Y is equal to f of x, some function of x. So you write change in y, that is delta y. So how do we write delta y? It is value of y at this point, okay, and value of y at this point minus value of y at this point. So at this point the x coordinate was x, y coordinate was y. Okay, so what is y? It is f of x, function of x, but x is changing. At this point it becomes what? X plus delta x. So at this point what does the y become? Y becomes function of x plus delta x. Okay, that's why what is change in y? It is value of y at this point, at this location of x, right, minus value of y at this position of x, right? So it is f of x plus delta x, because y is equal to what? F of x. So at this point x changes, x becomes x plus delta x, So y will become what? F of x plus delta x. And that's why we write it like this, f of x plus delta x. Okay, that's value of y at this point, minus f of x, its value of y at this point, divided by change in x. So this is change in y divided by change in x. Okay, remember we wrote, so what we are finding is delta y by delta x. So this is delta y, this is delta x. Is this definition clear, everyone? Yes, no? Okay, very good. So now we can take some examples based upon this. So I'm sorry, this is the geometric meaning of derivative. So how do we apply it in practice? So suppose y is equal to, which is f of x, so we are taking function x square. Okay, so suppose y is equal to x square. So f of x is x square. What will be f of x plus delta x? Just change the variable x to x plus delta x. Then f of x plus delta x becomes what? X plus delta x square. Right? So you can expand that, it becomes x square plus 2 times of x delta x plus delta x square. Then you take the definition. What is the definition of derivative? Dy by dx is limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Okay, so then you put that x square here, sorry, x plus delta x square, right, because it is f of x plus delta x, it's this thing, you put it here. So it is x square plus 2x delta x plus delta x square minus f of x is x square. Okay, so x square and x square will get cancelled here, and you are dividing that by delta x. So in denominator you have delta x. So this x square and x square gets cancelled. Then what you are left with is 2x times delta x plus delta x square. Okay, then you divide this numerator by the denominator and you are left with 2x plus delta x, right? And finally you are using the fact that your delta x is very, very small. Okay, so delta x is very, very small. You put that here, so you can neglect delta x. So you neglect delta x, then what remains is 2x. So it is the derivative of x square. Derivative of x square is 2x. This is clear? Yes, no? Okay. All right, good. Now nobody will ask you to derive derivatives using this formula, but this is just for the sake of understanding. Okay, we should understand what we are doing. Okay, that's why. Then you can take another example, y is equal to x cube. So what will be y of x plus delta x? Instead of f, I am just writing it as y now. So y of x plus delta x will be x plus delta x cube. Then you know the cube formula, right? A plus b cube. Okay, a cube plus 3 times of a square b plus 3 times of ab square plus b cube. That's the formula. What is your a and b? X and delta x. So using that formula, you expand it, x cube plus 3x square delta x plus 3x delta x square plus delta x cube. Then again, what is dy by dx? Its limit delta x tends to 0, f of x plus delta x, or you can say y of x plus delta x minus y of x. So you put that in the numerator, and in denominator you have delta x. Okay, again this x cube and x cube gets cancelled out. After that you have this thing is remaining, 3x square plus 3x delta x plus delta x square. Okay, and again you apply this limit that your delta x is very, very, very small. So the terms containing delta x get cancelled out and you get 3x square. So the derivative of x cube is what? 3x square, right? Derivative of x cube is 3x square. This is clear? I'm sorry. Right. Good. So now derivative of x square is 2x, derivative of x cube is 3x square. Then you can have derivative of x to the power 4. Okay, we can expand that also and find out its derivative. It will come out to be equal to 4x to the power 3. So there is a pattern here. If you keep on finding the derivatives, then you will see that if y is equal to x raised to n, then its derivative is n multiplied by x to the power n minus 1. So this is the formula that you need to remember. If y is equal to x raised to n, if y is equal to x raised to n, its derivative is n x to the power n minus 1, right? So you can see that here, you can check it for y is equal to what? X cube. So what is derivative of x cube? So according to this formula, what's the derivative? Write this n in front, okay, in multiplication, and the power decreases by 1, okay. So if n is equal to 3, what will be the derivative? It will be 3n, right? N is 3, x to the power n minus 1, that is 3 minus 1. 3 minus 1 is 2. So 3x to the power 2, that's the derivative. Okay, so you got this, right? So this is how you get the derivatives. This formula is clear? Okay, good, very good. All right. Then, so next thing is, now there are not only algebraic functions like this, there are trigonometric functions also. Okay, so for that, to find out derivatives of trigonometric quantities or trigonometric functions, we need to know some limits. So limit delta x tends to 0, sine of delta x is equal to 0. Okay, how is this? So you know that when angle is very small, what is sine 0? Sine 0 is 0, right? Sine 0 is 0. So if sine 0 is 0, that means any value which is closer to 0, for that sine of that angle would be very, very small. For an angle which is very close to 0, sine of that angle would be what? Very, very small. It will be almost 0. So that's why this is the limit. Okay, if delta x is very small, almost 0, then sine of delta x is equal to what? It's 0. Okay, so this is one limit. Then there is another one, limit delta x tends to 0, cos of delta x is equal to 1, because we know cos 0 is equal to 1. So approximately we can say, if the angle is very close to 0, then its cos is what? 1. Its cosine is equal to 1. Right? Then after that, now there is another limit, limit delta x tends to 0, sine of delta x upon x is equal to 1. Okay, you don't need to remember anything of this. I am just explaining, I will just take one problem based upon this. Okay, so for that I am explaining these limits. But this is good to understand. This is very good. Anyways, for the people who love maths and physics, of course. Okay, so suppose you have, suppose this is a sector, this is a small portion of a circle. Okay, so this is arc of a circle, right? So you know, how do we find the angle? We saw in the last lecture, angle is equal to what? Length of arc divided by the radius. Okay, if we find angle that way, its unit is radian. So suppose delta x is your angle. Okay, this delta x is your angle. How will you find it out? It is length of this arc AB divided by radius is suppose r, right? Length of arc AB divided by radius r. Then now you draw a perpendicular from here like this, and you want to find out sine of delta x. So what is sine of delta x? It's the opposite side divided by hypotenuse. What is hypotenuse here? Hypotenuse is also equal to r. Okay, so it is length of BC divided by r, right? Sine of delta x is length of this side BC divided by r. Now here comes a crucial point, a beautiful point, that for small angles sine of delta x is nearly equal to delta x. Why is it so? Okay, this thing, by the way, we need to remember sine of delta x, it's equal to delta x. Okay, it will keep on coming in oscillations, etc. Sine of delta x is equal to delta x. Okay, so see here, what is sine of delta x? It's length of this side BC divided by r. What is delta x? It's length of AB divided by r, right? If angle is very small, then you can see that this length is almost equal to this length, because this side is, okay, you can approximate this to be a right angle triangle. Approximately that's equal to a right angle triangle. So it will be AB square will be equal to what? BC square plus AC square, right? But if angle is very small, then these 2 points will be very close. These 2 points will be very close. That means AC is almost equal to 0. Okay, and therefore AB will be equal to BC, almost you can say. And if AB is nearly equal to BC, then sine of delta x will be nearly equal to delta x. I'm sorry. This thing is clear. For small angles, sine of an angle is equal to angle itself. Okay, if angle is very small. So then if you divide this sine of delta x by delta x, you get this thing. So when angle is very small, that is limit delta x tends to 0, sine of delta x divided by delta x is equal to 1. This is the limit. This is clear, everyone? Okay. All right. So this limit we are going to keep on using, that sine of delta x is equal to delta x, and also tan of delta x will also be equal to delta x, almost you can say. What will be tan? See, tan will be equal to the opposite side divided by adjacent side. And if AC is very small, then what you can say is, if AC is very small, this OC is nearly equal to radius only. Okay, OC is nearly equal to radius only. So you can also say that for small angle, sine is nearly equal to angle itself and it's equal to tan. Otherwise the relation would be sine of an angle, sine of delta x is less than sine of delta x is less than delta x, and it should be less than tan of delta x. But if angle is very small, all three are almost same, almost equal. Okay, sine of an angle is nearly equal to angle itself, it's nearly equal to tan of an angle itself, right? So this thing we need to remember for small angles. Sine of delta x is nearly equal to delta x, and it's nearly equal to tan of delta x when angle is very small. Alright, very good. So this thing we need to remember, right? After that, see, for an example, you have y equals to sine of x and you want to find out its derivative. Okay, y is equal to sine of x, you want to find out its derivative. So what's the formula? Dy by dx is derivative of y with respect to x. It is limit delta x tends to 0, y of x plus delta x minus y of x divided by delta x. Okay, so that is, what is y of x plus delta x? Because y of x is sine x. So y of x plus delta x will be equal to what? Sine of x plus delta x, right? Just one second. Okay, sine of x plus delta x. Then you expand this. So we know the formula. Yesterday only we learned what is sine of a plus b. It is sine a cos b plus cos a sine b. So using that, your a is x and b is delta x. So using that, it is sine x cos delta x plus cos x sine delta x. Okay, this is sine of x plus delta x, minus you have sine of x, right? Then what you do is you apply limits in the next step you apply limits. So you have sine of x multiplied by cos of delta x. So you apply limit delta x tends to 0 to this cos of delta x, right? So what is this thing? So we have just seen that limit x tends to, delta x tends to 0, cos of delta x will be equal to 1 because cos 0 is equal to 1. So if angle is very small, if it is close to 0, then cos of that angle is nearly equal to 1. So you make this 1, okay? So this thing becomes 1. Then you have cos of x sine of delta x. So then you have cos of x and limit delta x tends to 0 sine delta x upon delta x. Okay, so this is your complete function, sine delta x upon delta x. And we just saw that this limit is equal to 1. Okay, we just saw that this limit is equal to 1, sine delta x upon delta x, because delta x is nearly equal to delta sine of delta x. So this is 1. So what happens? So this is sine x into 1 upon delta x, right? So that is sine x only, sine x upon delta x, and here you have minus sine x upon delta x, so that thing gets cancelled out. And this thing is cos x multiplied by 1, so that is cos x only. So that thing only remains, and that's why what is derivative of this thing? It's cos x. So derivative of sin x is equal to cos x. This thing is clear? Okay, very good. So this is how we find the derivative of trigonometric functions. But now we cannot find out derivative of each and everything. So this is just for the understanding, sake of understanding. Then there are a lot of formulae that you will need to remember. You will need to by heart them. Okay, so I will share those formulae along with today's notes. So you will need to by heart those formulae, right? Let's see the next thing, the rules of differentiation. Okay, the rules of differentiation. So differentiation means derivatives. So we just saw how to take derivatives, right? Now there are, suppose addition of two functions. Okay, how to find out derivative of that? Subtraction of two functions, how to find out derivative of that? Then there is multiplication of two functions, how to find derivative of multiplication of two functions? All those things we are going to see now. So there are some rules. Derivative of a constant is equal to 0. Now you might ask, why is it equal to 0? Okay, so if you just plot the graph of constant, how will it look like? X changes but y is constant. Okay, so then what is your derivative? It is delta y, means change in y, divided by delta x, when delta x is 0, right? Almost 0. Okay, but is there any change in y? No, there is no change in y. So delta y is equal to 0. So that's why this derivative is equal to 0. So derivative of a constant is equal to 0. That's first rule. Next, suppose y is equal to f of x plus or minus g of x. There are two functions of x and you are adding them or subtracting them and you want to find out derivative of that. Okay, so what will be derivative? So it is just derivative of f plus minus derivative of g. Okay, derivative of f, first function, plus or minus. Okay, whatever sign is there. If it is addition, there will be plus. If it is subtraction, then there is minus. So df by dx plus dg by dx, or df by dx if there is negative sign, minus dg by dx. Okay, for an example, you have y equal to 3x square plus sin x. So what will be derivative of this thing? Now we know what will be derivative of x square, what is the derivative of x square, and what is the derivative of sin x? Tell me. So d by dx of 3x square plus d by dx of sin x. Tell me. Okay, derivative of this thing is 6x, right? And derivative of this thing is cos x. So this thing will be equal to, see, 3 will come out, then it is just derivative of x square with respect to x. Okay, then derivative of x square, we just found it's equal to 2x. Right, good. So 2x times 3 is 6x. So this is 6x plus cos x. Okay, so that is your dy by dx. This is my dy by dx. Right, very simple, addition or subtraction. So this is simple rule, right? Next one is the product rule or multiplication rule. So suppose y is equal to u times v. Okay, y is equal to u times v. So u is a function of x, v is also a function of x, right? So what will be the derivative of this thing? What is dy by dx? So it is derivative of first function with respect to x, second function as it is, plus first function as it is, derivative of second function with respect to x. Very, very simple, right? This is the formula. So derivative of first function with respect to x, second function as it is, plus first function as it is, derivative of second function with respect to x. Okay, so again let's try to apply this. So you have y equals to x cube cos x, and let's take derivative of this thing. So you have dy by dx is equal to d by dx of x cube cos x. So that is equal to derivative of x cube, derivative of first function cos x as it is, plus x cube as it is, derivative of cos x. Okay, first function as it is, derivative of second function. So what is derivative of x cube? It is 3x square, right? This is 3x square. So you have 3x square cos x plus x cube multiplied by, what is derivative of cos x? So we found, yeah, that's minus sin x, right? So if we know the formula, we can put it. Derivative of cos x is minus sin x. So it's minus sin x. Okay, so this is your answer. Now if you like, you can take x square common, but concept is up to this point only, right? That thing we can do in numericals wherever it is required. Okay, so the product rule is clear, everyone? Okay, good. All right, next is quotient rule, or you can say division rule. So what is the division rule? Y is equal to u upon v. Okay, u and v are functions of x. Then what is dy by dx? Then the quotient rule says that you write the denominator first. You start with the denominator. Okay, so dy by dx is, you start with the denominator. What is denominator? V. V multiplied by du by dx. V multiplied by derivative of the numerator minus dv by dx multiplied by, that is derivative of denominator multiplied by the numerator as it is. Okay, divided by denominator square. I'm sorry. Yeah, this is clear. Start with the denominator, write denominator as it is, take derivative of the numerator minus take derivative of denominator multiplied by numerator as it is, and in denominator you will write denominator square. Okay, so this is the formula that we need to remember, and then let's take derivative of this function tan x. Okay, we are learning quotient rule. So tan x is equal to what? We know tan x is equal to sin x divided by cos x. It is sin x upon cos of x, sin x upon cosine of x. Then what will be its derivative? So you have dy by dx, it's equal to derivative of this thing, d by dx of sin x by cosine x. So what does our quotient rule say? Start with the denominator, write the denominator. Okay, so it is cosine of x multiplied by d by dx of sin x, right, d by dx of sin x, sorry, and minus you have derivative of the denominator, so d by dx of cos of x multiplied by numerator as it is, multiplied by sin x, and in the denominator there is cosine of x square, cosine of x square. Okay, all right. So then what is derivative of sin x? We know it is cos x. Okay, so therefore dy by dx is equal to, you have cos x multiplied by cos x, so that is cos square x, minus derivative of cos x is minus sin x, and that minus minus becomes plus, right? So derivative of this thing is minus sin x, then there is another minus, minus minus becomes plus, so you have sin square x, right, because this sin x and sin x, it will be sin square x, so plus sin square x, and in denominator you have cos square x. Okay, so what is sin square x plus cos square x? That's equal to 1. Then you have 1 upon cos square x, so you know 1 by cos of x is sec x or secant x, then what will be 1 upon cos x square? It will be secant x square. So it is equal to 1 by cos square x or secant square x, and this is derivative of tan x, so you got another formula. Okay, so this is how the first you will find derivative of sin x, then cos x, etc., sec x, then okay, then what will you do? You have these relations tan x, so using the quotient rule you can find out derivative of tan x this way. Similarly you can find out derivative of cot x. Okay, so this is how other derivatives are found out. Anyways, so dy by dx sorry, derivative of what? Tan of x is equal to sec square x. Okay, secant square x. So this formula is clear, everyone? Okay, good. All right, so this is quotient rule. I'm sorry. Okay, we can see another example, derivative of sin x upon x. So now you tell me, speak up. What will be derivative of this? Dy by dx. Let's apply this quotient rule. Let's apply the quotient rule. Yes, anybody? Okay, what will you have in the denominator? What will you have? In denominator you have x square. Good. Okay, right. What about the numerator? You will start with the denominator, so it is x multiplied by derivative of the numerator, that's sin x, minus it is derivative of the denominator. Okay, so dx by dx multiplied by sin x as it is, right? Very, very simple. So derivative of sin x is cos x, so this is x cos x, minus dx by dx is 1, then you have sin x only, okay, upon x square. So this is the answer. Right, very simple. Yes, no? Okay, good. All right. Next one is chain rule. Chain rule of derivatives. Okay, this is the last one. Now, what is chain rule of derivatives? So, suppose f is equal to f of u, and f is some function of variable u, and u is a function of another variable x. F is a function of u is a function of x. Okay, f is function of u is function of x, but you want derivative of x, derivative of f with respect to x. You want derivative of this thing f with respect to x. Then what's the rule? So you want df by dx, no? So what we do is we divide by du, we multiply by du. Okay, so df by dx can be written as df by du multiplied by du by dx, right? So first you take derivative of f with respect to u, then you take derivative of u with respect to f, with respect to x, and you multiply them. Okay, so this is the chain rule, right? For an example, you have f is equal to 2x cube. So this thing can be written as u cube. So what is your u? It's 2x. What is u? 2x. So what will be the chain rule? What will be the derivative of f? So df by dx. I wanted df by dx, but I don't have x here. I have 2x cube. Okay. So first I can write derivative of this thing. Okay. So this thing can be written as u cube. So what is derivative of? So df by du multiplied by du by dx. What is df by du? It is derivative of u cube. Okay. I'm sorry. Derivative of u cube with respect to u. So what's that? It is 3u square. Can you see that, or it's very fine? Okay. So this is 3u square. Derivative of u cube is 3u square multiplied by, you have du by dx. So du by dx is 2x, right? So then what is u? U is equal to 2x. Then what will be 2x square? It will be 4 times of x square. So it is 3 times of 4x square multiplied by 2x. So 3 4s are 12. 12 times 2 is 24. 24 x square into x is x cube. So this is 24x cube. This is the answer. Okay. This is clear? Yes, no? Okay. So this was very simple example. Okay. Let's see another one. So suppose f is equal to sine of x cube. Right, f is equal to sine of x cube. So here you have f equal to some function of x cube, and we call that function as u. Okay, so you have f equal to u cube, right? Where u is equal to what? Here u is equal to sine x. Now apply the chain rule. It's simple. So df by dx is equal to df by du multiplied by du by dx. Okay, df by du multiplied by du by dx. So what is your f? It is u cube again. So d by du of u cube multiplied by du by dx. So this is 3u square multiplied by, what is du by dx? What is u? So u is sine of x, right? What is its derivative? It's cos of x. Then you have 3u square. Again you substitute u is sine x, so it is just 3 sine x square. Okay, or you can write it as sine square x. Sine x square is written as sine square x multiplied by cos x. So this is the answer. Okay, this is clear? Yes, no? Okay, good. Then we can take another example. Derivative of cos of x square. Derivative of cos of x square. So u is equal to x square here, right? So you can write f is equal to cos of u, then df by du into du by dx is the derivative of f with respect to x. This is the formula. So what is derivative of cos u? It's derivative of cos u with respect to u, right? And then u is equal to what? X square. So it's derivative of x square with respect to x. So that is cos u's derivative is minus sine u. Okay, derivative of cos is minus sine. So minus sine u multiplied by derivative of x square is 2x. And what is u? U is equal to x square. So just put that. So minus sine x square multiplied by 2x. Okay. So this is the answer. So this is how we apply the chain rule. This is clear, everyone? Okay, very good. So now, see, we will not have time to do all this in the exam. So what should we do? So instead of writing this thing, its first derivative of u cube, etc., etc., what we'll do is, so suppose you have this bracket cube. Okay, you want to take its derivative. So we'll see what's there in the bracket. It's 2x, no problem. So you have something raised to 3, derivative of that. What is the derivative? Apply the formula of x to the power n, derivative of x to the power n, n x raised to n minus 1. That's the formula. So it is this bracket, right? You will say 3 this bracket raised to 2. That's the answer of this thing. Okay, that will be your du by dx. Sorry, dA by du. Okay, so 3 this bracket square multiplied by derivative of the bracket. Okay, derivative of the bracket is 2, right? And then you can write what's there in the bracket. Got it? Yes, no? Okay, we need to apply chain rule, but apply it fast. So you have this bracket cube, no? So take its derivative. So assume that it's x only, or that bracket is something. You want to take it, you have bracket cube. What will be its derivative? 3 bracket raised to 2 multiplied by take derivative of the bracket. So there is 2x inside the bracket, derivative will be 2. And what's there inside the bracket? 2x. So shouldn't the answer be 24x square? Yeah, it's x square. Okay, by mistake I wrote cube. You are correct. Oh, that's because I wrote this thing incorrectly, right? Derivative of u with respect to x. U is 2x. Its derivative is just 2. I wrote 2x there. Okay, that was the mistake. Right? Okay, silly mistake. Anyways, you have any question till this point? Okay, all right. So then I actually explained this thing. Next, derivatives by inspection. You just see this thing and you write its derivative. Sorry. Okay, so what will be the derivative of sine of ax? A is just a constant, a number. So this is like sine of a bracket. What will be derivative of that? Cos of the bracket multiplied by derivative of the bracket. Okay, sine of the bracket, derivative of that will be cos of the bracket. So cos of ax is the derivative multiplied by derivative of the bracket. So what's derivative of bracket? A. So multiply that with A. This is clear? Right. Similarly, you have sine of ax plus c. Okay, you want to find out its derivative. So this is the bracket. What is derivative of the bracket? I mean sine of this bracket, its derivative is cos of the bracket. So cos of the bracket multiplied by derivative of the bracket. So derivative of the bracket is just A, because derivative of a constant is equal to 0. So derivative of ax is a, derivative of constant is 0. So what is derivative of the bracket? It's equal to a. Okay, very simple. Then you have cos of x square plus 2. For an example, you want to find out its derivative. So what is derivative of cos? It's minus sign. So it's minus sign of this bracket. Okay, minus sign of the bracket multiplied by, you have derivative of the bracket. So that is derivative of x square plus 2. So derivative of 2 is 0, derivative of x square is 2x. So you have derivative of this thing, cos of bracket, so derivative of that will be minus sign of the bracket, it's there, multiplied by, you have derivative of the bracket, which is 2x, and that's why this will be the answer. Okay, very simple. Then exponential function is a function, e raised to x is only one function whose derivative is the same function itself. Okay, its derivative is same function itself. So derivative of e raised to x is e raised to x only. I'm sorry. Okay, this thing we need to remember. Then what will be derivative of e raised to 5x plus 9? So we have e raised to bracket, derivative of that will be e raised to bracket multiplied by derivative of the bracket. So what's there in the bracket? 5x plus 9, take its derivative, derivative of that will be 5. Right? So this is how you can find out derivatives by inspection. Okay, very simple. Okay, good. Then there are some homework problems, okay, that you need to solve. It will be good if you solve it. For these kind of questions, descriptive questions, you can solve it and you can take photographs, make a PDF and send it to me. It won't take much time. Okay, so I can just check your understanding where you are, right? All right, then let's see next point. Next point is maxima and minima. Okay, so we understand derivative now very well. So let's understand maxima and minima. So what is this thing? Suppose you have some function and you have plotted it like this. Okay, there is some function and you have plotted it like this. What is maxima? So meaning is clear from the name itself. It's the maximum value of the function, right? What is minima? It will be the minimum value of function. Okay, so this goes up down like this. So now if you just look from here to here, this will be the maxima. Okay, so this is called as a local maxima. If you take for some values, certain values of x, for certain range of values of x from here to here, you find out maxima, that is called as local maxima. Then if you see the entire range of x, that is minus infinity to plus infinity, then you find the maximum value of this function, then that is known as the global maxima. So that is local maxima, global maxima. Okay, just nomenclature for us. Okay, next, then same thing. So here it's going up, coming down, okay, and it's hitting a minimum value, right? So if you just see this much range, this will be a local minima or local minimum, and if you see entire range, this one is global minima. Okay, right, everyone? Okay, then see now what happens at the maxima and minima, that we need to understand. Okay, so now suppose I want to find out slope of a curve. How do I find slope of a curve? What do I take? I take derivative, right? Yes, the most lowest and the highest one, it is called as the global. Okay, global minima, global maxima. Okay, good. So my question is, how do we find slope of a curve? What is slope of a curve? Derivative, right? It is slope of a tangent to the curve. Okay, slope of the curve, it's slope of tangent to the curve, right? So if I want to find out slope of curve at this point, it is good, it's derivative, very good. So I will find tangent to the curve and find out its slope, and that slope is called as derivative, we just learned. Okay, so then if you find the tangent at the maxima, how will the tangent look like? How will the tangent look like? Local maxima, global maxima, any maxima. So what is maxima? So this thing, this function goes to some high value and it returns back. Okay, so if you draw a tangent at that point, a tangent at maxima, the tangent will be parallel to the horizontal axis. Yeah, parallel to x-axis, very good. So this will be parallel to x-axis. That means what is its slope? It makes no angle to the x-axis, right? 0, very good. So slope is equal to 0. Okay, slope of this line is equal to 0. That means slope of this curve at the highest point is equal to 0. Okay, slope of the curve at lowest point is also equal to 0, because there also, if you draw a tangent, it will be parallel to it will be parallel, sorry, yeah, it will be parallel to the curve. Again, it will be parallel to x-axis, not the curve. It will be parallel to x-axis. Okay, so its slope will be equal to 0, right? So derivative is equal to 0. Okay, so at maxima, at minima, what's the derivative? The derivative of that function, whatever function we are plotting, derivative of that function will be equal to 0. Okay, this is clear? Yes, no? Right. So now how to check whether a particular point is a maxima or a minima? Okay, that's what we need to understand. Derivative is 0. At maxima, minima, derivative is equal to 0. Now, next thing to understand is how to check whether it's a maxima or a minima, because at both points the derivative is equal to 0. Okay. So for all maximas and minimas, the derivative will be equal to 0. Okay, local is not an exception, global is not an exception. Everywhere, at every maxima minima, derivative is equal to 0. Then see here, now if you take any maxima, this is the maxima. Okay, so before the maxima, if you draw a tangent line, it will be like this. You take any point before the maxima, so the slope is like this. Slope is positive or negative? Slope is positive, right? Positive. Good. After the maxima, how is the slope? If you draw a line after the maxima, the line will go like this. Let's take some different color. The line will go like this. Okay, I want a tangent here, let's say. Okay, so line goes like this. So how is the slope? Is positive or negative? It's negative, right? After maxima, the slope is negative. Okay, so here I can say, if I find the slope, dy by dx is positive. Slope is dy by dx, we know, derivative, it's positive. And after the maxima, dy by dx is negative. Okay, here. Right, this is clear, everyone? So dy by dx here it's negative, dy by dx is positive here. So now if you find change in dy by dx as you go from this point to this point, okay, or as you cross the maxima, right, as you cross the maxima, what will be change in dy by dx? Will it be positive? Will it be negative? It will be negative, okay, because here dy by dx is negative. So let's say it's -1, something negative value, okay, this thing is positive, and if you want to find out change, that is difference in this thing and this thing, what will you do? You will take this thing, okay, let's say it's -a, and you want to find out difference, okay, so this is positive, so difference is minus of this thing, this can be anything, let's say b, so minus a minus b, so this whole thing will be what? Negative, right? So this difference is negative. If you take that difference, divide that difference by delta x, change in x, okay, and apply limit delta x tends to 0, limit delta x tends to 0, so that will be the second derivative, okay, are you getting this? That will be the second derivative. You're taking first derivative, okay, how do we find derivative? What is definition of derivative? Limit delta x tends to 0, y at x plus delta x minus y at x divided by delta x. This is the formula, right? This is derivative of y with respect to x, okay. Now suppose this point is x, or you can say x1, this point is x2. You are finding out dy by dx at x2 minus dy by dx at x1. So what you have found is difference in dy by dx, okay, at x2 and x1, and denominator therefore will be, if I take denominator equal to x2 minus x1, that's my delta x, which is equal to what? X2 minus x1. And if I apply the limit delta x tends to 0, so that will be double derivative. See, it's difference in derivative, okay, when you change x by delta x divided by the delta x, and when delta x tends to 0. So if this difference in derivative is negative, that means if you take this quantity, it will also be negative. But what is this quantity? It is double derivative, okay, it is derivative of a derivative. Is this thing clear? Yes, no? Everyone? Okay, very good. So then at maxima, the change in slope is negative, means second derivative, that means derivative of a derivative is going to be negative, okay. So this will happen at maxima, the double derivative will be negative, and what will happen at the minima? The double derivative will be positive, because you can see the minima, this is minima. Before minima the slope is negative, after minima the slope is positive. That means before minima the derivative is negative, afterwards it becomes positive, right? So it is positive value minus a negative value. If we find change in derivative, it is positive value minus a negative value, so this difference is going to be positive only, okay. So that's why the double derivative is positive. So that's the difference between maxima and minima, okay. So you can take derivative equal to 0, and you can find out all points at which this thing happens, derivative becomes equal to 0, you get all those points. Then you need to check at a particular point what is double derivative. If double derivative is negative, that means it's a maxima. If double derivative is positive, that means it's a minima. Now this is example in physics. A potential energy of an oscillator is U equals to 3x square minus 12x. Find the position at which U is minimum. Okay, so first of all, what will we do? Let's find out du by dx, because we know at minimum what happens to the derivative? Derivative becomes equal to 0, right? At maxima minima the derivative is 0. So first of all, let's find out derivative. So du by dx is equal to what? It's equal to d by dx of this thing, 3x square minus 12x, right? Okay, it is 6x minus 12. Very good. So it is 6x minus 12. That is equal to 6x minus 12. Okay, and therefore you have 6x equal to 12, because at maxima minima, at minima, du by dx will be equal to 0. Okay, so put that equal to 0. So you have 6x minus 12 is equal to 0. Okay, so therefore 6x is equal to 12. Therefore 6x is equal to 12, right? And therefore x will be equal to 12 by 6, that is 2. And there is only one point at which derivative is equal to 0. So that means this has to be minimum, because in question they are asking find the point at which u is minimum, right? So it is at x equal to 2. If there is a question like this, then we don't need to check further. Okay, but we will check because we are trying to understand this concept. Okay, so let's check whether it's minimum or maximum, because we know at maximum and minimum at both points what happens, derivative of function becomes 0, but at the minimum the double derivative is positive. So let's take double derivative. So what is double derivative? d2u, it's written this way, d2u by dx square, it's double derivative I'm sorry, d2u by dx square, and that's equal to d by dx of du by dx. Okay, so that is equal to d by dx of this thing, du by dx, which is 6x minus 12. Okay, so derivative of this thing is what? Derivative of 12 is 0, derivative of 6x is just 6. So double derivative is 6, and therefore, yes, tell me, Pawana.
I'm trying to reply the answer, sir.
Okay, yeah, tell me.
6 is the answer.
Yeah, 6 is the answer. So you should speak up, because when I write, I can't see the
Yes.
screen. Okay, that's why I'm
O-
asking. You should speak up. At least speak up.
o-
Okay,
Okay, sir.
good. It's applicable to everyone. So 6 is the answer. Okay, very good. And it is positive or negative? It's positive,
Positive.
right? Double derivative is positive, and that's why it is maxima or minima.
Minimum.
Okay, very good. Okay, so Vishalini, you should speak up. Okay, all right, good. Okay, so 6 is the answer. I mean, 6 is positive, and that's why this is the minimum. Minima is the answer. Okay, so where is the minima? At x equal to 2, right?
Sir, is the double derivative is to check whether it's minimum, right?
Yeah, you need to check it. But if there is a question where you I'm sorry. Okay, there is a question where they are asking you to find out a minimum, and you get only 1 point. Sorry, you get only 1 point. Then,
Okay, sir.
then that's the answer. Then there is no need to check,
Okay, sir.
right? Then there is no need to check. Okay, this is
Then
clear.
we can check it, sir.
If there are 2 points, then you need to check at which point the double derivative is positive, at which point it is negative.
Okay, sir.
Okay,
Okay, sir.
good. Then we can take another example. I want to explain one thing. So suppose you have sine x. This is the function. Okay, what's the function? Sine x, right? and you want to take you want to find out its minima and maxima. So find maxima and minima. This is the question. Find maxima and minima of sin x. Okay, but you want to find it between 0 and 2 pi. Okay, you want to find it between 0 and 2 pi. So see, your function is sin x, y is equal to what? Sin x. If you take one derivative, okay, take its derivative. So what will be dy by dx? Dy by dx is cos x, right? Dy by dx is cos x. And then now at maxima and minima, you have this derivative equal to 0, right? At maxima as well as minima, the derivative will be equal to 0. So cos x is equal to 0 at maxima and minima. Cos of x is equal to 0. Now tell me, where is the cos x 0?
Cos 90.
Cos 90 is 0, right? Cos 90 is 0. Where else will it be 0? Where else will it be 0? If I plot the graph, okay, one example, the graph of cos x, it will start from the maximum value like this, it goes to 0, okay. So this is 0, this is 90 means pi by 2, at pi by 2 the cos x is equal to 0, right. Again it will go to a minimum value here, okay, then it comes back, it goes to 0 at this point. So this is 180 degrees because cos of 180 is minus 1, but if you want to write it in radians, it will be pi. This is 3 pi by 2, and again it goes to maximum at 2 pi, right. So there are these 2 points where it goes to 0, okay. So you have x1 equals to cos of x is equal to 0, and it happens at 2 points where that is cos of pi by 2 is 0, cos of 3 pi by 2 is 0. You got these 2 points, right. Okay, cos of pi by 2 is 0, cos of 3 pi by 2, 3 pi by 2 is also 0. But now which of these is a maxima, which of these is a minima, that you need to check, right. And how to check? Find out double derivative. So yeah, good. So let's find double derivative. So d2y by dx square is equal to, tell me, minus sin x. Good, it is minus sin x. Okay, derivative of cos x is minus sin x. Okay, so double derivative is minus sin x. Now take these two values. This is suppose x1, one is x1, so x1 is equal to pi by 2, x2 is equal to 3 pi by 2, right. X1 is pi by 2, x2 is 3 pi by 2, okay. Right. So what is the value of minus sin x? So now this is minus sin x, so d2y by dx square at x1, okay, that is pi by 2, is equal to minus sine of pi by 2 is 1, we know that, right, minus sine pi by 2, and that's equal to sine pi by 2 means sine 90, sine 90 is 1, and therefore this thing is minus 1. So this x1 is maxima or minima? Tell me.
Maxima.
Maxima. Good. Okay, good. This is the maxima because the double derivative is negative. And what will be x2 then? So let's check d2y by dx square at x2, which is equal to x2 equal to 3 pi by 2. Okay, it's equal to minus of sine of 3 pi by 2 is sine of 270 degrees, and sine of 270 degrees is minus 1, right? So that is minus 1 minus, okay, that minus minus becomes plus, and you have plus 1. Okay, so the double derivative is positive, means it's a minima. Good, it's a minima. Okay, so I'm just shrinking it. So pi by 2 has pi by 2 is maxima, right? There is a maxima at pi by 2, and there is a minima at 3 pi by 2. Okay, so sin x has a maxima at pi by 2 and minima at 3 pi by 2. Okay, and what would be the value of that maxima and minima? Tell me. What is the maximum value of sine? Yeah, maxima is 1 and minima is minus 1. Good. Okay, this is clear, everyone? Okay, good. Now we should know this maxima and minima. All right, then let's see this problem. The height of a particle thrown upwards is given by this thing. Find the time taken by the ball to reach the maximum height. Okay, this is the question, physics question, right? So h is equal to ut minus half of gt square. This is the height of a particle thrown upwards, and so h is function of t, and we want to find out the time at which the height is maximum. Okay, time taken by the ball to reach the maximum height. That's what we want to find out. Okay, so we know at maximum height, that is the maxima, dh by dt would be equal to what? 0, right? dh by dt would be equal to 0. So just take that. Okay, so you have u derivative d by dt of ut minus half of gt square is equal to 0. Okay, and that is what will be derivative of ut. So u is a constant, its initial velocity, and you can take it out. Then its derivative of t with respect to t, yeah, that's 1. So therefore this derivative is equal to u, minus you have half of g multiplied by derivative of t square. So derivative of t square is 2t. Okay, so this 2 gets cancelled. U minus gt is equal to 0. U minus gt, okay, u minus gt is equal to 0. That means u is equal to gt. U is equal to gt, and therefore time at which there can be a maxima or minima is equal to what? U by g. Yeah, u by g. Now next thing is checking whether it's a maxima or a minima, right? Next thing is to check whether it's a maxima or a minima. So let's check that. I'm sorry. So what will you find out? What happens to the double derivative at this point? So take d2h by dt square, that's double derivative. That means derivative of this thing dh by dt, and your dh by dt is this thing u minus gt, that is derivative of u minus gt. Yeah, so it is minus g. Okay, so it's minus g is 9.8 meters per second square, so this is negative, that means it's a maxima. Okay, so therefore h is a maxima. At t equal to u by g. And how to find out that maxima? Just substitute t equal to u by g in this formula of h. So if you substitute t equal to u by g, then this thing will become u square by g minus you have t square. Okay, we can substitute that and find out. All right, so this is our height. This is the equation for height. So for h max, you have t equal to u by g, right? U by g. So t equal to u by g, we have h max, maximum height. So h max is equal to u times t is u by g, okay, minus half of g multiplied by t square, that is u by g square. Okay, so then it is u square by g minus, then it is half of g multiplied by u square by g square. So the g and the square gets cancelled out. Okay, meaning there is g times g in the denominator, one of that gets cancelled out with this one. Okay, so often I say that square gets cancelled out. Okay, so this thing will be u square by g minus half of u square by g. So 1 u square by g minus half u square by g is half u square by g, or you can write it as u square by 2g. So that is the maximum height. Okay, this thing is clear, everyone?
Yes, sir.
Right, very good. All right, so then this completes maxima and minima. Okay, so now these are too many topics. So next one we'll see, will introduce integration. Okay, today you need to revise everything else before we understand integration. So you need to revise everything that we do today, okay, so that we understand the integration. All right, so here I will explain the concept. Okay, so see, now personally I like to explain this thing in terms of the motion. Okay, so suppose there is some object which is moving, right? Some object is moving and you plot its position versus time graph. Okay, so suppose I am walking like this and you plot my position versus time graph. So this is position which I am plotting on vertical axis, time I am plotting on horizontal axis. Okay, so then now the graph looks like this, something like this, and if you want to find out my average velocity, what is average velocity? So you know velocity is equal to displacement divided by time. What is the velocity? Displacement upon time. And what is displacement? Displacement is change in position. Okay, change in position divided by the time is my velocity. But what's that velocity? It is the average velocity in time interval from t1 to t2. Right? You can call that interval as delta t. Okay, so if you see that on the graph, this is the point P. Okay, at time t1, if you want to find out my position, so what I will do is I will draw a perpendicular from t1 on the graph, it meets at this point, and from there I will draw a perpendicular on position axis and I locate my position. Okay, so I was at position x1 at time t1, then I go from t1 to t2, right? So at t2 I want to find out my position, So for that I will draw perpendicular on the graph, it meets at this point, and from there I will draw perpendicular on the position axis, okay, and I locate my position. So I was at position x1 at time t1, I was at position x2 at time t2, right? And what is my average velocity? It is difference in position x2 minus x1, okay, divided by difference in time t2 minus t1. So average velocity, v average, is displacement by time, that is x2 minus x1 divided by t2 minus t1, okay. And if you see that here, it's slope of this line, okay, it is slope of this line which is known as secant line, okay, slope of this, it is slope of this line, right? Then now if you take that time interval smaller and smaller, what will happen? That line will approach closer and closer to the curve. And if you want instantaneous velocity, means there is no time lag, you ask for the velocity, you get the velocity, okay, you ask for the velocity, you get the velocity, okay, there is not even this much time lag, okay, that the time that I am taking to say you ask for the velocity, you get the velocity, there is not even this much time lag, so time interval is almost zero. Then what do you have? Then in that time interval which is almost zero, you find out the velocity, okay, that means your t2 is coming closer and closer and closer to the t1, and when that happens, what will happen? This line whose slope gives you velocity, it comes closer and closer and closer to the curve, okay, and at one point what will happen? It will touch the curve, it will become tangential to the curve, right? And therefore when that line becomes tangential to the curve, what's the time difference? It's almost zero, okay. So instantaneous velocity is the velocity which is found in delta t tends to 0, okay, and it can be said as velocity at a particular time because there is almost no time lag. Delta t tends to 0, time difference tends to 0, and when you do that thing, what do you get? If delta t tends to 0, okay, so this is equal to, then I can say that instantaneous velocity, I will call it v, it is limit delta t tends to 0, limit delta t tends to 0 of change in x, x2 minus x1 by t2 minus t1, or you can say it's equal to limit delta t tends to 0, limit delta t tends to 0 of delta x by delta t. So what's that? So we have been learning the same thing, okay, over this lecture. It is dx by dt, it is derivative of x with respect to t. So this thing is clear, everyone? The instantaneous velocity is derivative of position with respect to time. Okay, so this is the application of derivative. Not only this, there are lots of applications, right? But first the derivative came in this way. The instantaneous velocity is derivative of position with respect to time. And do you know who discovered derivatives? Any guesses?
No, sir.
No problem, okay. So it is Newton, right? So Newton discovered derivatives. All right, no problem. Okay, so he was one of the greatest physicists, and he was one of the greatest mathematicians also. Okay. Anyways, next let's see. Now suppose you have a velocity versus time graph. Okay, what do you have? You have a velocity versus time graph, and suppose you want to find out displacement. So what do? So let's take this very simple graph. Okay, this is very simple graph. It's a straight line, means velocity is constant. Okay, so average velocity can be written as what? Change in position divided by change in time. but here the velocity is constant. Okay, so therefore if you take that change in time on this side, what do you get? You get displacement, which is x2 minus x1 is equal to the velocity multiplied by t2 minus t1. Okay, and because that is constant only, velocity is constant, I can directly multiply by that, or it's the average velocity in this time interval, and in this particular example it is a constant. Okay, so x2 minus x1 is average velocity multiplied by time difference. Okay, and therefore you can see it over here. So this is the average velocity, it's this much, that means it's this much, right? This is the average velocity. And what is time difference? It is this much. So from here to here this is t2, from here to here this is t1. So if I want to find out t2 minus t1, it will be t2 minus t1 is equal to this thing. So you are taking time interval from t1 to t2. Okay, and you locate 2 points on the curve. This is first point, this is the second point, right? And you take area under that curve. You take area under the curve. Okay, so what do you get? You will get length of this side multiplied by length of this side. Okay, what does length of this side multiplied by this side give you? It gives you area under the curve. And you can see that length of this side is V average. Okay, length of this side is t2 minus t1. So if you do multiplication of those things, you get the displacement. And what does that mean? It means that the displacement is area under the velocity versus time curve. Okay, the displacement is area under the velocity versus time curve. This thing is clear, everyone? Okay, very good. So displacement is area under the velocity versus time curve. And this curve was simple, very simple. So you can very easily find out the area because this is just a rectangle. Okay, it's length of this side multiplied by length of this side. Okay, length into breadth, very simple. But then suppose you have a curve like this. So velocity versus time graph looks like this, and you want to find out the displacement. What will you do? Displacement from t1 to tf, t2, or initial time ti to final time tf. So I have written something over here, but can you think what can you do? We cannot find out area under this curve, this kind of curve, or this kind of curve directly, right? And your velocity, it will not be constant, it can be anything, right? I mean, it may be constant, it can change also. So graph of velocity versus time, it may be a straight line like this one, or it might be anything like this one. So what we do is to find out area under the curve, because area under the curve will give us what? It will give us displacement. Okay, so I want to find out area under this curve from initial time to final time. Initial time is ti, yeah, and final time is tf. Good, Vishalini. So what we do is we divide this curve in small segments. Okay, n equal segments you can say, and those number of segments would be very large. Okay, so you divide it into small segments and you try to find out the area of one segment, right? So what I will do is, if you see it over here, so this is the curve. I have divided it into n number of small segments, and width of all those segments is equal to delta t. I am calling width of all those segments equal to delta t, right? So this is delta t, this is delta t, this is delta t, it's same. Okay, then see here, I can say that velocity at this point is v1, and if I draw a straight line from here, if I draw a straight line like this, okay, if I do v1, okay, v1 is this much times delta t, which is this much, I will get area of this rectangle. Okay, I will get area of this rectangle, right? And I will just say that it is velocity, area of the velocity time graph from this point to this point. It is not actually, okay, this is an approximation, because of what? There will be this much error. What is the total area under velocity time graph from this point to this point? It will be this area, this total area, right? This total area. Okay, so if I just say that it is area of this rectangle, I am neglecting this part, this portion. So that will be the error. Okay, are you getting this? So I will say with some error. Okay, with some error, approximately the area under velocity time graph is area of this rectangle. Okay, with some error, right? Then I will find out area of all those rectangles, areas of all those segments, and approximately, not correctly, approximately it will give me area under this curve. Okay, approximately that gives me area under this curve, right? So what is area under a curve? So area under this curve, approximately, I have written approximately here. So it is V1 delta t, right? Then area of this rectangle is V2 delta t, plus area of this rectangle, it will be V3 delta t, so on and so forth, up to we are dividing it in n segments. So last term would be Vn delta t, right? And I will add it all. I will get area under the curve. Okay. So now see here, I had taken big segments. Instead of doing that, if I take same curve, I am just taking same curve and I am dividing it into smaller segments. Okay, small segments. Then see what happens. So compared to this case, here the error was big. If you take smaller segments like this, so error is reduced, right? So number of segments would be more, okay, but error will be reduced. This thing is clear, everyone?
Yes, sir.
Okay, so number of segments would be large, and by taking larger number of segments, that means smaller segments, what will happen? The error will reduce. Okay, and then I can write the same thing. So then I can say by little more confidence that area under the curve is actually V1 delta t plus V2 delta t plus so on and so forth up to plus Vn delta t, right? Then what you can do is you can take delta t common, and then if you take delta t common, it will be just sum of V1 plus V2 plus V3 so on and so forth up to Vn. Or you can write this thing as summation. This is summation. Okay, I hope you know this. Do you know this symbol, everyone?
Yes, sir.
Okay, this is a summation. I goes from 1 to n of Vi delta t. Okay, so I goes from 1 to n means when I is 1, it will be V1 delta t. When I is 2, it will be V2 delta t. Okay, so then summation sign means you will take I equal to 1, you will write the term V1 delta t, then you will take another value I equal to 2 and you will write V2 delta t, okay, and you will add them. So for all values you will keep on adding, right? So that is the meaning of summation sign. So you can write the area under the curve, area is equal to this thing, okay. And then now if the time interval between t1 and t2 is divided in more number of segments, so number of segments tends to infinity, I can say I want to divide it into infinite segments. So what will be the area of width of one segment? It will be almost 0. Okay, so delta t will be almost 0, and if I divide it into infinite number of segments, so what will happen to the error? Error will become 0. Okay, this thing is clear. The error will become 0 because you are dividing it in more number of segments, so error is reduced. If you divide it into infinite number of segments, what will happen? Error will become 0, error will vanish. So I can definitely say, so this was with little more confidence, so this is perfect relation that area under the curve will be limit n tends to infinity, so n is number of segments is infinity, summation of this thing, okay. So how many number of segments are there? Infinite number of segments are there. So when this limit, when number of segments tends to infinity, this summation is called as an integration. Okay, the summation is called as an integration. And when number of segments is infinite, that means you are taking a continuous addition. Okay, you are taking continuous addition. Those points are very, 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 very close to each other. Right, this thing is clear. Then we write this thing as, if n tends to infinity, we replace this symbol with this symbol. Okay, and we write v times dt. Okay, so dt means, it means that t is a variable. You are changing t from t1 to t2. So this t1 is called as the low limit, t2 is called as an upper limit. Okay, this thing is clear, everyone? I'm sorry. Okay, good. So then, so what is an integration? What is the integration? It is limit n tends to 0 of summation of something from 1 to n. Right, when this n becomes infinite, then the summation is called as an integration. Okay, so this is the meaning of an integral. So we are doing the same thing actually. We are taking an infinite sum only, but we are calling it as an integration. And if you see the sign, if you see the symbol of integration, it is just elongated s. It is just to remind us that we are taking nothing but a sum. Okay, s is for sum. This is symbol of integration. S is for sum. Okay, right. So then now you might ask how to do this infinite integration. You will not ask because you have some experience, right? So we don't need to do that because some great people have done it already. Okay, and they have come up with some rules. Okay, so we just need to see those rules, right? By the way, so what will this area give us? What will the area, this exact area, yeah, it will give us displacement. So area under the velocity time graph gives us displacement. So that means displacement is area under velocity time curve, and if velocity time curve is not flat, what will you do? Then the displacement x2 minus x1 is integral of v dt from t1 to t2. Okay, it's integral from t1 to t2 of v dt, and this is known as the fundamental theorem of calculus. Not this one, this is actually, see, what is this thing? Velocity, its derivative of x with respect to t. Okay, what is velocity? Derivative of x with respect to t, right? So how to go from displacement to velocity is you take the derivative of displacement or derivative of position, you get velocity. Okay, so derivative of one gives you another, right? Derivative of, so v is equal to, you know, dx by, actually I have written it here. So velocity is given by, instantaneous velocity is given by dx by dt. Then change in position is given by, okay, change in position is given by integration of v dt. So see, derivative of x is equal to v, integration of v is equal to x, you can say. Derivative of one gives you another, right? Derivative of x gives us v. So if you integrate v, you will get x. So that's the relation. Okay, this thing is clear, everyone?
Yes, sir.
Okay, good. So now we'll stop at this point and we'll talk about this thing and integration more tomorrow, right? But before that, you need to understand everything that we have done today. Okay, if you have any doubt, you can ask me.
Sir, in 12th, the next which chapter is test, sir?
In 12th, there is one test is uploaded. Now we can discuss that. Okay, I will tell it to you. Yeah, apart from
Okay,
that,
sir.
okay, good. So we'll stop here then. Okay, please revise this thing because this will keep on coming. Okay, so we'll stop here and have a good day. Right, bye.